Hello everyone, MK is here. You all are welcome to my YouTube channel. Today we are diving into a fundamental topic that forms the backbone of many concepts in physics: motion in a plane. In this video, I'll guide you through the fascinating world of two-dimensional motion, where we'll explore how objects move in a plane using vectors. Vectors are essential tools in physics because they allow us to describe both the magnitude and direction of quantities like velocity and acceleration. Understanding vectors will help you grasp more complex topics in mechanics and beyond. We will start with the basics of motion in 2D, breaking down how to represent and analyze the movement of objects using vectors. You will learn about the direction of average velocity, how it provides insights into the overall motion of an object over a period of time. We will also delve into instantaneous velocity, explaining how it captures the exact speed and direction of an object at a specific moment. To make these concepts more concrete, we'll take an in-depth look at oblique projectile motion, which is a classic example of motion in plane. We will break down the components of projectile motion, showing you how to resolve vectors into their horizontal and vertical components. This will help you understand how projectiles travel and how to predict their paths. By the end of this video, you will not only have a solid understanding of motion in a plane, but also the confidence to tackle relative problems with ease. Whether you are preparing for exams or simply curious about the wonders of physics, this video is designed to equip you with the knowledge you need. So this class, I'll be discussing the motion in two dimensions by using vectors. So before we do that, we need to learn what is position vector and displacement vector. Suppose there is a origin O and there is a point P. If we say that position vector of the point P is R, then from origin to P, if a vector directed, that will be equal to R. Okay? So if position vector of a point P is R, then with respect to the origin, I am writing this one as PV. PV, our position vector of the point P be R, then OP vector is R. This is always true. Origin you can take anywhere. From there, the point P will be, if a vector directed from O to P, then this will be R. Now, suppose there are 2 points, P and Q. Then, position vector of the point P be P, small p, and Q be Q. Join these two. There is origin. So let position vector of the points P and Q be P and Q respectively. Then, by the concept of previous topic, that position vector, we can refer this vector OP as P and OQ as Q. It's quite obvious, OP vector is P and OQ vector is Q. Now the question is, can we express PQ vector in terms of position vector of two extreme points? Let's try. We want to express PQ vector in terms of P and Q. So in triangle OPQ, OP plus PQ equal to OQ. So PQ going to be OQ minus OP. This is nothing but Q minus P. Alright. So PQ vector, this will look like a formula now. If they have asked you to find a vector PQ, then you will write PQ vector is equal to position vector of Q. Sorry, this point is Q. Position vector of Q minus position vector of P. This will be like a formula only. Suppose somebody has asked you to write what is AB vector. Then AB vector will be position vector of B minus position vector of A. The second point comes first. Now, in this diagram, suppose there is a point R which divides it in the ratio m is to n. Then we can state that this is joining O to R. Then let R divides PQ in the ratio m is to n. Then position vector of P is given by R vector equal to m into Q plus n into P by m plus n. This is known as section formula. So what is section formula? That if a vector R divides the join of P and Q in the ratio m is to n, then position vector of that point which divides it in the ratio m is to n is given by this thing. That is mq plus np by m plus n. Can be proved also. Just let me show you the proof. Quick method. So when you are saying R divides PQ in the ratio m is to n, then this implies that PR by R cube is m by n. This implies n into PR, m into PQ. Now, what I am going to do there, I just make an observation. This vector and this vector have the same direction. So, can I put arrow above this? Of course we can. If they are directed along arbitrary vector, you multiply by I, that it is directed along the vector. Say I am taking I cap. Assume. Then we can multiply both sides by same thing because they are directed in the same direction. So M into PQ I cap. This implies that N into PR vector M into PQ vector, because I cap gives the direction. Now vector can be taken above PR, vector can be taken along above PQ also. So what is happening there? Now we will be putting PR vector. PR vector is what? Position vector of R minus position vector of P. We are going to do that. So just put, this implies N into position vector of R is R vector minus P vector M into Q vector minus R vector. Take this MR on the left hand side. If you take MR on the left hand side, then R into M plus N going to be MQ plus NP. So R vector is NP plus MQ, or write MQ plus NP divided by M plus N. So this is like coordinate geometry. In coordinate geometry, this solution exists. And here also we can write R vector this manner, MQ plus NP by N plus N. If R be the midpoint, it may be the midpoint also. So if R be the midpoint of P and Q, then we can write R not vector, just R is the point here. Then you can write R equal to Q plus P divided by 1 plus 1. That is P plus Q, that divided by 2. So this is midpoint formula. This you keep in your mind. It will help you to solve many problems from vector. Although section formula not given in your textbook, but you must know it. Now, with the help of this position vector and vector expression of PQ in terms of two extreme points, I can define the displacement vector. Position vector part you have understood. So now it is displacement vector. In 2D, we are going to discuss motion in plane. Plane means 2 dimension. This computer board is 2-dimensional. In 2D, suppose a particle goes from the point A to this point B by following a curve like this. Particle going from A to B via this curve, not a straight line. If you say the displacement vector will be AB, okay, I agree. But particle need not move along the straight line here. It is going along this curve. The displacement vector is this. In 2-dimensional coordinate system, if you look at 2-dimensional coordinate system, then this point might have a position vector A. We are taking A. And this one B. You join O to A. You join O to B also. O to A join and O to B also joined. Now this displacement vector, like the previous concept, AB displacement vector. So if we write AB as the displacement vector, then AB vector going to be B minus A. That is, you know the formula, position vector of B minus position vector of A. So AB vector going to be B minus A vector. Some book you will find this one as R vector, R dashed, and this one as R. Don't be confused. Instead of B and A, they are taking this. You can write R dashed minus R. Clear? Now, this point A might have coordinate x1, y1, and this one x2, y2. Then we can easily express OA vector. OA vector can be written in terms of unit vector along x-axis and along y-axis. This we have done in previous sessions. So if we take j cap unit vector along y-axis, then you express this R dash vector or B vector, whatever you see. OA vector is x1 I cap, y1 j cap. OB vector is x2 I cap, y2 j cap. So AB vector is going to be OB minus OA, that is x2 I cap, y2 j cap, x1 I cap. So this we can write x2 minus x1 I cap plus y2 minus y1 j cap. Alright. Now some people will say that this x2 minus x1 can't I write as delta x? Of course you can write, because if you draw a perpendicular here, and draw a perpendicular here, this is already explained. This part x1 and this one is x2. Similarly, this is y1 and this is y2. So delta x stands for what? Delta x stands for change in x. x2 minus x1 and delta y. This is your delta y. This is delta y. Delta y stands for what? y2 minus y1. So you can write AB vector equal to del x I cap plus del y j cap. Okay. Now the question is, what is the direction of displacement? Obviously, displacement is directed along AB. Some people write this one as delta R also. That R dash minus R, no, they write delta R. So you can express it in this manner. Delta R equal to delta xi plus delta yj. So in two-dimensional motion in a plane, displacement in 2D means displacement along x-axis and displacement along y-axis. So these are two just components, delta x and delta y. These are two components of the vector delta r. We have taken this one as delta r. This is delta r. Delta r vector is r dash minus r or b minus a, whatever you say. But delta r is delta xi plus delta yj, and it is directed along AB. So now if you go to this point P on the curve, go to the point P on the curve, What is the direction of displacement there? Your answer will be, it is parallel to the vector AB, isn't it? At this point, the direction of displacement will be along AB. Clear? So, AB, that vector we have taken, this is our consideration. But particle moving, it is not ready to follow that one. For our calculation, mathematical calculation in physics, we are defining all these things. Displacement vector, position vector, section formula, all these things. Now, if somebody has asked you this question, you have defined displacement vector. Is it possible to define velocity vector there? And what is the direction of velocity vector? Of course, we can find. You just assume that, like changes in x and y, let time taken from the time of B minus time of A. I mean time taken to go from A to B, be delta t. Okay, delta t change of time, that is t2 minus t1, tb minus ta, whatever you say. In this relation, delta r equal to, you take this one as equation 1, this one as equation 2. We are going to define velocity in two-dimensional coordinate system. Let us divide both sides by dividing by delta t. This implies delta r by delta t, delta x I cap, delta y j cap by delta t. So this you can write as delta r by delta a t equal to delta x by delta t I cap, delta y by delta t j cap. Now this delta r by delta t we can write as V average. You write this one as V bar or V average. And this part is what? Delta x by delta t. This is Vx, velocity along x-axis, plus velocity along y-axis. You write Vxi, Vyj. Alright? So average velocity along any direction is average velocity. If you have written V bar here, you put V bar here also. Okay? So average velocity will be directed along this direction, Vx bar I plus Vyj bar. Now the question is, what is the direction of average velocity? Will it be similar to delta r? Yes. At any point, average velocity will be directed along delta r vector. This is very important. Conceptual question can arise from here. So, you'll be writing a note over there that phi equal to V average is directed along delta r, that is displacement vector. If displacement vector directed along delta r, average velocity will be directed along delta r. Now we are going to define instantaneous velocity. The way we have defined it for direction along x-axis or y-axis in case of one-dimensional motion, we have to see whether the average velocity can be defined in two-dimensional coordinate or not. In that case, you try to remember it was tangential, no, in one dimension. Will it be tangential here also? Let us check. So average velocity, displacement vector, well-defined terms are there. Now this is your x-axis, this is y-axis. particle is moving along this curve. Particle going along this curve, say from A to B. Displacement vector, you know it already, you have done it. It is directed along AB, and average velocity vector directed along delta R. This is delta R, and this is the direction of V average also. Same direction. Now, if you want to define velocity at a particular point, suppose you want to define velocity at A, then that is known as instantaneous velocity. So if you consider velocity at A, then you just go for this approximation here when delta t tending to 0. You take this one as equation 3. When B tending to A, that is delta t tending to 0, we put limit over there, limit delta t tending to 0, delta r by delta t will be limit delta t tending to 0, delta x by delta t I cap, delta y by delta t j cap. So this thing is what? By calculus, we can say that it is dr by dt. This is the definition we have done in first principle, and this is what? Dx by dt I cap. I need not put arrow on x, and this will be dy by dt into g. Clear? So dr by dt, that is velocity, is going to be dx by dt I cap, dy by dt j cap, and instantaneous velocity also you can write this form, that is v. Instantaneous velocity at A we have defined, at any arbitrary point we have defined, it is Vx I cap, Vy j cap. Same thing, but this is instantaneous. This will differ as instantaneous velocity. This Vx and Vy, dx by dt and dy by dt. Previously it was del x by delta t and del y by delta t. That I told V average. This is V instantaneous. Now, a very important question. What is the direction of this instantaneous velocity? Try to understand the approximation here. Look at the diagram. We want to define velocity at A, and we have assumed that B is tending to A. Then only instantaneous velocity at A can be defined. You just do the approximation. You take gradually this point B from B to B1, from B1 to B2. This way you take very close to A, that is BI. Okay? So A to BI, BI is the position which is very close to A. In that case, if we join AB vector, then direction of average velocity parallel to AB, direction of average velocity AB1, that will be parallel to AB1, AB2, that will be parallel to AB2, ABI, it will be parallel to ABI. So what is happening there? It is gradually, this chord is tending to be tangent at A. Isn't it? Tangent means there will be just one point of intersection. It will be tangent at that point here, at the point A. Okay? So we'll see that average velocity, instantaneous velocity at a point is tangential to the path. This is very important for you. So direction of instantaneous velocity show the direction of instantaneous velocity at a point, obviously. At a point is tangential to the curve at the point. This you never forget. So in 1D what you have seen, 2D also true, but it is conceptual part. And I have explained by approaching that chord to tangent. So we have understood direction of instantaneous velocity at a point is tangential to the curve at the point. Now a question, can you define acceleration also? Instantaneous acceleration? Yes, that also you can do the same manner. I don't want to waste much time here. Just I'll tell you the expression, how it comes. Okay, graphical approach, hope you have understood. If we drag the expression from here, what have I got? V average velocity is delta x by delta t, or that Vxi Vyj. If we drag the expression from there, we can define acceleration in 2D. Let us define acceleration in 2D. Acceleration in 2D. We have V average equal to delta x, okay, you write delta x by, you write Vxi plus Vyj. This will help. V average is Vxi plus Vyj. This I have explained. Now just differentiate with respect to t. So d dt of V average will be d dt of Vx I cap plus d dt of Vy j cap. Clear? So this implies this V average, its derivative with respect to t, this is going to be average acceleration, A average. This will be A average along x-axis. Similarly, A average along y-axis. This symbol stands for average. A y bar means it is average along y-axis. A average into j cap. Clear? Now again you assume that let delta t tending to 0, then a equal to what? That this is average acceleration. This expression stands for average acceleration. If we want to define instantaneous acceleration, let us define it. That instantaneous acceleration, A will be what? Limit delta t tending to 0, delta v by delta t. Okay? This is the same manner. This can be written as dv by dt. A vector you can write as dv by dt. This is nothing but dv by dt. And again, like previous question, that dv by dt, this instantaneous acceleration, also acceleration along dvx by dt I cap plus dvy by dt into j cap. This is nothing but ax I cap ay j cap. Okay? So average acceleration, instantaneous acceleration, also can be defined. This is instantaneous acceleration. Just you write dv by dt. Don't write a vector. dv by dt. If you write a vector, okay. But here a stands for instantaneous. Now, what will be the direction of average acceleration? Average velocity direction change you have understood. What will be the direction of instantaneous acceleration? Average acceleration will be directed along that direction specified here, that axi, ayj. Instantaneous acceleration also has two components, that is ax, ay can be written axi plus ayj. But can we show it in terms of velocity vector? This way, that a equal to delta v by delta t we have seen. So suppose a particle goes in such a manner that at a point A, its velocity is v1. At the point B, its velocity is v2. We take the origin. We take velocity vector v1 means there is a origin. With respect to the origin, this vector will be directed this manner. v1 vector directed this manner, v2 vector directed this manner. It can happen. It can happen. In case of particle moving in a circle, it's going from this point to this point. Velocity vector changing, no? This is the direction of v1 and this is the direction of v2. It can happen. Our problem is to find the direction of average velocity. Instantaneous velocity accordingly will be there. Then in this triangle, what do you observe? In triangle OAB, OA plus AB equal to OB. Therefore, AB vector is OB minus OA. AB vector is OB minus OA. That is, this AB vector now I am taking as change of velocity, delta V vector. So delta V vector going to be what? V2 vector minus V1 vector. Okay. So if you want to find the direction of average velocity or instantaneous velocity, then it will be better you draw the vector triangle showing position vector of v1 and v2, and in that triangle you show v1, v2 and delta v. So delta v will be along AB direction. Okay. Now acceleration, instantaneous acceleration is also defined. This is the time to apply the concept of all these two-dimensional motion, theoretically what we have done in practical field. Okay. Practical field means you will find its application in plane where the particle moving with constant acceleration. What will be the equation in that case? Okay. So let us write equation of motion in a plane with constant acceleration. Equation of motion in a plane with constant acceleration. That acceleration vector be A, then you can write v vector equal to v0 vector plus a vector into t. Okay. This v0 stands for what? Initial velocity in plane. A is the uniform acceleration. This A stands for uniform acceleration. V0 stands for initial velocity in plane. In the plane. And t the time elapsed, then V will be equal to V0 plus AT. See, this equation we can write in plane. This is in plane. But if you go by component, then V vector is what? Write this V vector as that Vx I cap plus Vy j cap. V0 vector you write V0x I cap V0y j cap. Then if you put it there, I just show you one calculation. If you put it there and then compare V vector, you write it there that Vx I cap plus Vy j cap equal to V0x I cap. V0 you write first, you write V0. That will be V0x I cap plus V0y j cap, and you can write acceleration vector also. How do you write the acceleration vector? It also has component ax I cap, ay j cap. Just replace this term a by this thing, that is ax I cap ay j cap. So now what you will do, you write Vxi Vyj equal to, t is there. You write V0x plus axt I cap plus V0y ayt j cap. So you can write Vx equal to V0x plus axt and Vy equal to V0y plus ayt. Okay? This is your concept. So anything in two dimension you consider that is made of two one-dimensional cases. We can write, this is the first equation of motion. Number one, we can write other equations of motion accordingly. Like if we write a initial position of the particle be r0 and after time to this point be a, whose position vector r0, at the point p it is r, then AP vector is what? AP vector. I want to write this equation S equal to ut plus half t square. How it is defined over there? This is in one dimension. How does it arise here? So here displacement vector is dr. You can write the displacement vector r minus r0 equal to what? That initial velocity be v0. This is two-dimensional case plus half at square. So therefore r equal to r0 plus v0t. V0 is a vector, a is also a vector. Why? What is the difference between this equation and this one? Here we can express everything without arrow, motion in 1D. But here we cannot escape arrow because motion in 2D and this is made of two one-dimensional motions. Whenever you are writing equation, better you write this form. Now this equation, like previous one, it has equivalence in terms of velocity along x-axis and displacement along x-axis. We can write x equal to x0 plus v0 xt plus, like previous one, this is t square, ax into t square. Also we can write y equal to y0 v0 yt plus half ay into t square. Clear? So motion in 2D is nothing but two one-dimensional motion. All these equations you have seen before. Normally you take r0 equal to 0, so r equal to v0t plus half at square. It is comparable with this equation. So x will be ut plus half at square, y also in that, ut plus half at square. So this is the concept of two-dimensional motion in plane. With the help of this, a relative velocity can be stated. With the help of this, we can explain the projectile motion. So we are going to start projectile motion now. In projectile motion, we apply the concept, we got it there, that x equal to, or these three equations will remain operative throughout the topic of projectile motion. First, let us discuss the case where there is a projectile thrown from some point on the ground, where I will be taking the origin. This is our origin. From here, we are projecting a particle. This is the horizontal direction, which is taken as x-axis. This is your x-axis and this one y-axis. Imagine from the point you have thrown it, that is taken as origin. The vertical direction is y-axis, the horizontal direction is x-axis. Initially velocity directed this way, but it will not remain directed that manner forever. Why? Because G will be controlling its motion, the acceleration due to gravity. So obviously, particle, this is a common experience, by following a curved path, will touch the ground after some time. And this is the case of oblique projectile. It is not projected horizontally, that's why I will be referring as oblique projectile. Projectile fired from the ground. You just look at the three expressions I have written over there. This is our origin. So x0, y0 will be 0. So putting x0, y0 equal to 0, x going to be what? Let us write r first. What r going to be? Let us see. r0 means what? It is x0y, y0j. You have chosen origin at this point. So this is 0y, 0j. So r will be what? 0 vector plus v0 vector into t plus half a vector into t square. And these three equations, let it be our equation 1. And these two equations, if we take the components along x and y axis, these two can be rewritten, that x going to be equal to, because you have taken x0, 0, it is going to be v0 xt plus half axt square, and y equal to v0 yt plus half ayt square. Clear? And those velocity vectors, those also we have written, vx and vy. Let us write those also. Vx is equal to v0x plus ax into t. Number 4, vy equal to v0y plus ay into t. Why not third equation? Third equation also can be written that v square equal to u square plus 2x. It also has components. We can write vx square equal to v0x square plus 2ax into displacement along x-axis. 2as, no? Writing x, and then vy square will be ay into sy. Alright. So here projectile motion, all the equations of motion we are going to write in terms of the equations of motion I have written. Don't be confused with Sx and Sy. You can take x also. No problem. As I have written x, that's why I am writing Sx. Displacement along x-axis. Now see what is happening. It will follow the curved path. This is a common experience. Gradually, we will find the equation of the path, the velocity at a point, the maximum height and time of flight. Also, we will find this range where it strikes the ground. Clear? So let us do that. So initially, when you have projected, say I am taking the velocity of projection as u and projected at an angle theta. Then you easily can write v0x. Let initial velocity of projection be u. Then v0x will be u cos theta. So in this diagram, v0x will be u cos theta, v0y will be u sin theta. So this is true for all 7 equations here. I mean all 6 equations here, because we are writing in terms of x and y. We will be using equation 2 to 7. Now we use the first equation because we have drawn the 2-dimensional coordinate system. At an arbitrary instant, it will be situated at some point like pxy. So let us know that position. What position is there? If we find position, from there the trajectory can be determined. Let me do it step by step. So let us write from 2. From 2 what is happening? X equal to v0x is u cos theta. U cos theta. I did not write the component of acceleration. See, acceleration going to be what? This is unit vector. This is also unit vector. Then this g vector is what? It is g into minus j. So ax is 0. It has no component along x-axis. Vertically downward, no component. But ay is there. Ay is g, downward. This g is downward. So ax will be what? 0 into t. So this is becoming x equal to u cos theta only. I am taking this one as equation A. Y going to be what? v0y. v0y u sin theta. U sin theta. Here I am using this equation. Y t plus no minus. Because g downward, minus half g t square. Clear? So, although it is 2-dimensional motion, we have reduced it to 1-dimensional motion concept. Therefore, the position of a particle. This I have written position after time t. This goes under the heading of position after time t. That xy I have written now. That xy is given by this x and this y. It is derived from this equation. Now we are discussing motion in a plane in 2D. In 2D, what will happen? Everything can be discussed in terms of the trajectory it follows. This is called trajectory. The path followed by projectile is called trajectory. This trajectory equation I am going to find. So this t, one thing, this x, it will be multiplied by t. I forgot to multiply by t. This is half 0 into t square. I have used this equation for first one, not this one. So u cos theta t plus half 0 into t square. So this will be u cos theta into t. Motion along x-axis is not controlled by gravity. So this is the case of uniform motion. Along x-axis, motion is uniform. Along y-axis, it is controlled by g. It is controlled by g. So these two equations will help us to get the equation of the trajectory. See how I am getting it? With just t is like parameter, we eliminate t from 1 and 2. Eliminating t from A and B. So if you eliminate t from A and B, what do you get? To eliminate t from A and B, I am taking t from here. This t is x by u cos theta and put it there. Y going to be what? U sin theta into t by u cos theta minus half g, wait a minute, t we have taken, it will be x by u cos theta and half g, you are replacing t by x by u cos theta. So this is going to be y equal to x tan theta minus 2u square cos square theta. Clear? So this is the equation of trajectory. This is the path followed by the projectile. Trajectory. Trajectory or path followed by the projectile. This projectile is not fuel. I mean, it is in motion. It is in flight in atmosphere without being propelled by any fuel. Okay, this is projectile. So trajectory, the path followed by the projectile, is given by this. What equation is this? See, parabola equation is y equal to ax plus bx square. In motion in 1D, you have seen that graph of a is equal to ut plus half at square. When you are plotting it, the graph will be parabola. It opens upward for a greater than 0 and opens downward for a less than 0. All these things you know. Similar equation I got here. So this will represent a parabola. You will learn in class 11 mathematics in details. It is there in class 11 coordinate geometry. Right now, this projectile followed a parabolic path that you need to know, that I have explained. So this is a parabola, which is a parabola. It is of the form ax plus bx square, so it is definitely a parabola. So projectile will follow the parabolic path. Now position we got and equation of trajectory also we got. Next I am going to explain velocity at a point. Velocity at a point. How to find it? This is very easy. At this point, say we want to write velocity. This velocity vector will be tangential, that I have explained why it is tangential, that we have seen before. Component of velocity will be directed this way. This we refer as v0x, and component this way, v0y. Okay. So this is velocity here. v0x will be what? Along x-axis velocity direction is not changed. I mean velocity magnitude also not changed. So v0x is u cos theta, and v0y, that velocity of projection remains the same, we assume u only, and theta, this way it is u cos theta, you know, and this way it is u sin theta. v0y equal to u sin theta minus gt. So this is the expression for velocity. This I am taking equation D. This is equation E. This equation of path followed by the projectile, that we are taking equation C. A, B, C. A stands for position along x-axis, B stands for position along y-axis, C stands for trajectory, and D and E for velocity along x-axis and velocity along y-axis. So if someone asks you after time t, can you tell me what is the direction of velocity? I mean this direction, how do you find? This we can find by using vector. It is v0, because they are rectangular components. It will be v0x by v0y. No, sorry, it is v0y by v0x. So v0y is what? That is u sin theta minus gt by u cos theta. So alpha is tan inverse this divided by u cos theta. Okay. So alpha is tan inverse u sin theta minus gt by u cos theta. This way you can get the angle. After getting angle, we are interested to find the time of flight. From O to A, how much time it takes. Time of flight, let us find first. Time of flight. T. How do I get? What equation will help us? To understand it, we will see the displacement of the particle in going from O to A. Displacement of the particle in going from O to A. You will say, what question is this? Along x-axis displacement is OA. Definitely. But displacement along y-axis is 0. So, horizontal displacement equal to A. We will find its value in going from O to A. Horizontal displacement OA. It is not equal to 0, it exists. Vertical displacement. Vertical displacement, it has no displacement along y-axis. So vertical displacement is 0, and this will help us to get the value of time of flight. I'll be taking the equation I have already used. The position along y-axis is u sin theta minus half gt square. This will help us to get that y. I'm writing here y equal to, we have u sin theta into t minus half gt square. This is a general relation. Displacement along y-axis, we can get it this manner for any instant. But when it goes from O to A, that is in time t equal to t, when t equal to t, y equal to 0, no vertical displacement. So 0 is u sin theta into t minus half gt square. Just little bit simplification is required. Let us do it. So this implies half gt square is u sin theta into t. So t going to be what? 2u sin theta by g. This is called time of flight. This is time of flight. Time taken by projectile to travel in space before it strikes the ground is this 2u sin theta by g. Now, if somebody has asked you to find the horizontal range, how to find it? Horizontal range. For horizontal range, I'll be observing one thing here. For horizontal range, this I am doing it here only. Horizontal range. This is nothing but R. For horizontal range R, we write it is velocity along x-axis, this multiplied by t to strike the ground. U cos theta 2u sin theta by g. This is going to be, we have done this relation in trigonometry. 2 sin theta cos theta is sin 2 theta. This divided by g. R equal to u square sin 2 theta by g over there. This is for horizontal range of the projectile. We'll make some observation here, but let us derive all the relations first. I'll tell you how this thing can be used in sports. R equal to u square sin 2 theta by g. But wait, let us find the vertical range. What is the maximum height the projectile can travel above the ground? This is called vertical range, h. This h we can find by using the third equation on motion for vertical range. For vertical range, just recall that equation, that v square equal to u square plus 2as, that I am going to apply. Same projectile motion, same velocity of projection u, angle of projection theta, this way u cos theta, and this is u sin theta. This height we are going to find. Okay, this height. Sorry. this height we want to find. This is called vertical range. This is h. This we want to find. So just making one observation here, where we'll find that this u cos theta remains the same at all points. Here also, before striking the ground also, every point horizontal velocity is u cos theta. But vertical velocity will change. What is the vertical velocity here? This is v0x. Here v0y will be equal to 0. So at the top of the trajectory, v0y equal to 0. So 0 equal to 0 square equal to u sin theta whole square minus 2gh. Okay. So this will give us h equal to u square sin square theta by 2g. This is the expression for vertical height. Hope you have understood, because initial velocity in this direction is u sin theta. We use this equation vy square minus 2asy. Sy is the vertical displacement, v0y is u sin theta. I've used that and I got the vertical range. H equal to u square sin square theta by 2g.